Welcome the next speaker, Kush.
So hey, my name is Kush. I'm going to talk about the evolution of search. It's basically a history talk about the developments in the field of information retrieval over the last uh, millennia, centuries, last few decades, and what's going on right now. What's up? Cool. So yeah, because there's going to be a lot of stuff, I'm going to try and rush through it without rushing through it, hopefully. So initially, just about me, primarily a software engineer in terms of how I make money, but my background is film and animation and industrial design, and I just build stuff for myself usually, and then I fund that ability through freelancing for our clients. So yeah, that's how I do stuff. And so whatever knowledge you see here is very, like scrapped together from just what I care about. It's not representative of anyone who is making informed, assessments. Okay, so what problem are we solving really? It's information retrieval, right? So we have a lot of information. We want to find the right piece of it at the right time. That's fundamentally what we're trying to do. You can imagine a room of unmarked boxes, lots of boxes, and you want to find certain information that you know exists in one of them. Now, of course, one approach is to go through all of them one by one, and that would be, too much. It would take too long. It would take forever, and increasingly forever as time moves on. And so the idea is, how can we retrieve it faster and get to that information in the time that we need it? So not just find the right information, but also when we need it. So yeah, let's move on to the first topic, which is I wanted to see when to start the story, and because just I wanted to do it as far as back as possible, I started at like 700 BC, which is before writing has taken over in terms of information retrieval at all. So initially, of course, we are humans. We have brains and some and memory. So people were trying to recall just things from their mind initially. One of the techniques for doing this retrieval just from your mind, often used by speakers actually, and when they were giving speeches, was using this thing called the method of loci, which is like memory palaces. So if you've heard like a memory palace recently, maybe in Sherlock, the TV show, or whatever, it comes from that time, that far ago, 700 BC or whatever, Greek and Roman Empire. And so, actually before that, yeah. And so, what that method was, this, by the way, is just a representation of something different than a memory palace called a theater of memory. It's by an artist, a philosopher from the 1400s. I just modeled it up because it looks cool to look at and think about. It's, by the way, 3D, if you didn't know. Basically, a memory palace was a technique where you would project information spatially onto a space that you're familiar with. And so you wouldn't have to memorize the space itself, but now you're associating different objects with items that you want to remember, let's say during the course of a speech, each of the beats that you want to hit, right? So as you would do that, you would then be able to enable yourself to recall later on when you're giving the speech, simply walking through that space and recalling the objects and the information wherever you placed it. So this was one technique before the written record that people were using. Okay, so of course, the one big problem with that is, what do we do as we want to share information, as we want information to last for longer than a single lifetime. In fact, longer than a single evening, because these memory palaces for speeches would really only last for so long because you have to maintain this memory, right? So one great way to do it was the written record. So people started write. Of course, as we started to write stuff down, initially on tablets, then on scrolls, and so much more, the next problem is, how do we keep track of what's been written down? How do we find what's been written down? And so what we do there is, even as far back as I said, in 700 BC, in the library in Syria, which had a lot of tablets at this library, they started to basically add these things called colophons towards the, I think, bottom area of the tablet, each tablet, specifying the author, the subject, just a couple of pieces of information that basically would serve as metadata. So if you've heard of metadata, and that concept is around everywhere, that was metadata. That was the initial invention of it. I mean, again, as I tell the story, it's important to understand that I'm only telling certain parts of it that either we as humans know, or parts that I can cover in this talk. But it may not be the actual first, but it is that far ago that people started to think about, how can we have a little bit of aboutness of this document that is captured in some part of it. That way we can prevent ourselves, or enable ourselves not to have to read the entire tablet, but rather just look at a part of it as you're scrolling through looking for the piece of information you want. So that's happening. Of course, as things scale up in the Library of Alexandria, 300 BC or 3rd BC, we have, 300. We have like 500,000 scrolls, like by some approximation, which is a lot of them stored everywhere. And so even this idea of tagging scrolls, and there were various ways that people would do that, was not enough, because even if you did, walk around the entire library and look through all the tags to find the information you wanted, that's too much work. So this librarian, Callimachus, working at that library during his period, comes up with this thing called embeddings, which is basically a map of the shelves. So a separate scroll, or actually a lot of scrolls, that were dedicated specifically to documenting where information was. So this was one of the first instances, perhaps the first instance, of an index that lives outside of the document itself. So an index that is referencing various scrolls that are documented, and then this index, again, he had various ways in which he would structure information. So author, subject, certain lines from initial lines from the document, perhaps a summary. Really is quite cool. Like that far ago, they were already thinking about this idea of an index, and we use exactly that technology right now. So there's a lot of lessons from history that are worth thinking about. As we move forward into the next thousands of years, I'm going to jump to the printing press, where it really blew up the supply of knowledge sharing. We had printers in every city. We had a lot more information being produced, a lot more people who were now literate and looking for information. And as a result, now you have the problem of, how do we know what's even out there? There's just too much information. You don't even have like a single library that has all of it captured. So you can just be like, I'll just go there, and that's the information place. Now you have the problem of, how do you actually find out what's out there? This Swiss guy, Konrad Gessner, this is like, I forget when the date is, but he comes up with this publication called Bibliotheca Universalis, which is trying to capture thousands of authors from around the world, having published different subjects, different books on different subjects, so that you could now, and then this published, so you can now have that as a resource to access global information being published. This was, I think, one of the first efforts of this kind, where you would now have this shared index, not just at a library, but around the world, being distributed. So briefly, in 1605 and around that time, people are also not just thinking about how do we catalog just books by themselves and what they represent as knowledge that you can find later, but also how do we organize knowledge in general? Like, do we organize it through themes? Do we organize them through domains? Francis Bacon has this contribution in 1605. He's talking about having memory, reason, and imagination, which is like 3 axes in which you can pretty much categorize all knowledge. And so people are trying to come up with cool ways to say, this is humanity, this is how we want to organize information, so that you can truly walk down a path of subcategories and subcategories and subcategories to be able to get what you want. Frankly, I was quite happy to see that even in Alexandria, the Phoenix by Callimachus had a miscellaneous section, because I always have a miscellaneous section in my directories. They're the largest ones, obviously. But even then, they acknowledge that there's documents you simply could not place well enough. So as time is passing by, oh, by the way, I should probably just do this little visual for that. Books, as you hover over them, they kind of tilt up, whatever. I was having too much fun with 3JS. So they basically, people started to come up with classification systems, which was a way to universally organize information in different libraries, so that you could then walk into any library in the world and be able to understand where to look for information. The Dewey Decimal System is a great example of that. Vancouver Public Library uses that. The various other libraries, it's obvious. And so as we start indexing information globally, people start to ask, can we index everything that humanity has ever written? And can we do it in a way that is perhaps distributed, not just concentrated in one place? One great effort towards this was by these Belgian guys, Paul Otlet and Henry Lafontaine, which was called the Mundaneum, which was basically this, I guess initially it was a building, it was a place where they had just like lots, like there's walls of these shelves with card catalogs, which was basically an idea introduced by Charles Carter a while before that, which would have which would capture the documents that exist about given knowledge with more facets than just the subject, the headers, and so on, but rather different angles that people could be coming at them. So something about them that might help someone else find that information better. Before I jump off this point about this library, this was a distributed system in the sense that people would be able to basically mail in their questions, and then they would, on paper, they'll figure out and then write the answer and send them back to people around the world. This is a global effort by these guys. And so just quickly, the idea of classifying information from various angles, not just top-down classification, became quite in vogue around the time. One of the guys, S.R. Ranganathan from India, a librarian, was talking about how basically a set of rules or a set of laws that he was writing about the philosophy change in this field. Let's organize information not for the librarian to find for the user, for the reader, but rather organize information for the reader itself. And these card catalogs and other efforts were somewhat in that direction. In fact, he talked about facets, this idea of multiple dimensions, in such a way that you can think of a straight line being drawn from that to filters for e-commerce websites. Category, brand, price. These are, you can see the echoes in what he was talking about back then. What else? So yeah, like I said, almost a paper-powered, search engine exists. This is like the 30s, I guess, which leads kind of nicely into the invention of computers or the proliferation of it. And as computers are now in a lot more places, people are starting to wonder, what if we could use computers to process information, process text as data, just data, not sacred literature that we have to read and understand the meaning of, but just as raw information, and perhaps manipulate it, do something with it that would be useful. In this effort, one of the first people that really started to play and process information was Hans-Peter Lune at IBM. This is like, I forget what the year was, but he introduces this idea of automatically extracting abstracts from documents by using the frequency of words that occurred and having certain normalization around how often some baseline words occur everywhere. And another concept of keyword in context in terms of how to display that information, which was or quick, which was basically how you can draw a line from that to Google 10 blue links, where if you see like, here's my search query, and here's my search query in the context of where it appears in the document. He's talking about it then, and they're building systems like that already automated with computers. And even now, it seemed like a really great way to display information, at least for the last 20 years that Google and other people were using it. So again, the solution there was yes, and I'll get more into the statistics part, but also mechanized indexing. So if there's too much information, we need to handle the scale, and so now we're going to use computers to even abstract the metadata about those documents. Next question was, and by the way, no more visuals here. There's like a visualization at the end, but I ran out of time. So next question is, could relevance be quantified? This is an awesome contribution by this guy named Cyril Cleverton in Cleverton, this library in Cleverton, aeronautics library, where he started to think about how could we measure the fact that we're doing retrieval and so on now with computers. And he came up with a specific data set, a curated data set of documents, as well as queries, and then gathered the judgments of people around in that field of what was relevant and what was not, and how many for each query. And as a result, now he had a ground truth data set that he could use against various algorithms, and he published it as well. So people could now use against the various algorithms that they were approaching for retrieval. And this, funny enough, was actually one of the first contributions of this kind into the field, where people really started to measure it electronically. And so now you can actually compare approaches across the world and actually say, my approach for doing this is better, or the old school way of just this or that is better. Two concepts that he introduced that you may now be familiar with are precision and recall. This is Cleverton's work. Precision being how many of the documents that were retrieved by a given mechanism were relevant, and recall being how many of the relevant documents that exist were actually retrieved. Maybe it sounds like a tongue twister, but if you think about it twice, it's pretty obvious what it's saying, and it's very cool. So this data set, this publication, as well as these sort of guidance around how to measure, became a sort of force to really expedite research and the comparison of it between people. Building from that, next question becomes, how do we tell signal from noise? Basically, as we are now, again, ever having increasing amount of data, as well as we process text, through computers, perhaps there's a way in which we can enhance the signal. Perhaps there's a way in which we can actually truly get to the essence of each document better than simply treating each word as equal. So let's see, what do I want to talk about? Okay, so the most exciting development around this field was this by this guy named Gerard Salton, which he introduced the vector space model. So if you've heard of like vector search, vector databases, this is from like the 70s, so like 50 years ago. So if you're using it right now, it's from back then. And he introduced this idea of creating basically a vector. A vector is basically like a set of coordinates in a point in space, or even on a very simple level, it's just a list of numbers, right? So the list of numbers, perhaps in his approach, could be derived from, let's say you have a vocabulary of 10,000 words that exist in English, and you have a vector which is like a list of numbers, and you basically are going from word counts. So has this count, do has this count, horse has this count in the given document. Most of them probably 0, some of them quite high, and some of them highlighted. So this is basically a list of numbers, but you can use it as a coordinate in space, in obviously more than 2D space. But as a result of this, and if you do the same thing for the query that the user is asking, you could now compare, just on a very simple level, you could compare the two vectors, the two lists, and have a certain sense of the relevance of the document to the query. It just worked, and there's many approaches that build on top of it, and we're still using it. We're just exploring better and better ways of building those vectors, better and better ways of comparing them, or just making them more real time, and I'll get into that in a moment. And so one key insight that I realized that it came from this period was by this colleague of Gerard Salton, Karen Spark Jones, and she talked about how if we not just deal with the frequency of the terms in a given document, but also how often they appeared in other documents as a signal for how they may be less relevant since they appear all the time. This became a very important insight, because now you could have just automatically, without even sort of a heuristic saying the and common words should be ignored, we simply say if these words appear in all the documents more often, just weight them down. So if you can imagine that list of coordinates, you're simply multiplying by a certain number to make that number go down for each term in the vocabulary. And the development on this many years down the line is called BM25. Did I say TF-IDF? So TF-IDF is the term in what Karen Jones was talking about, term frequency, inverse document frequency, and BM25 was a polished a version of that algorithm where they said also you should normalize for the length of the document, because if the document is longer, they might just be that each term is just represented more often, and that kind of biases the results towards longer documents. So a way to make up for that was to simply normalize for that. Some cool stuff in that. There's a lot of stuff that I'm skipping, but in the interest of moving through the timeline. As we're now looking at signals from the text itself, we also start to ask, with the rise of the web and people connecting even more data to each other, was what additional signals now exist that we could use to derive relevance, to derive meaning, than just the document's content itself. One of the things was, of course, links. So if people are linking to a given document, if other web authors who are producing and publishing content are linking to other content, that is a signal that they have vetted this piece of information, and as a result, we should treat it as more relevant. As well as we could have the hyperlinks, for example, on the internet, and the text that they paste in that link to your website as an additional piece of metadata. So you could basically be like, oh, this is user-generated metadata for free. I don't even have to write it about my own book or my own website. Someone else wrote about me, and we should use it as a signal because it probably means something. Google did this a lot with PageRank and so on, and they also used other signals as time evolved, like sort of this entity graph called knowledge graph, where you basically say we can have various aspects about a given piece of information. For example, for a person, we can say age and association and occupation and so on, and explicitly map it out in a database that we can then use to walk through and say, find this person's occupation, find all the people that are in that occupation, find the common ones in the city. And so you can really do like mathematical operations on that. So the next thing is basically a continuation, but a modern one of the idea that Gerard Salton introduced, which was vector space model. What if we could map ideas into space? This is the thing that I have a visualization for at the end, which is embeddings. So people really started to, in the last 10 years, I would say, and a little bit more, explore approaches where you could simply use now the big data that you had and the big amount of compute that you had to just throw it at it and try and train these vectors out of that, as opposed to using linear algebra by hand in this approach called LSI earlier, or so much more. So now with the scale, we simply kind of like had that bitter lesson happening where just throw compute at it and you might actually get something out of it. One of the approaches in there was word2vec, which was the idea of just using word frequencies that are available in the text that around the world. And another thing was glove, and so you would just say if two words appear together in the corpus of the internet, however small subset of it, then they must be related just across billions of sentences. And as a result, you can train a model that just recognizes that these things are similar. Eventually, you have something like BERT and sentence BERT, which is the idea is you don't just do for specific words, how close words are to each other, but rather entire sentences and entire paragraphs of sentences. This is the foundation of current vector search. If you've been using vector databases or embeddings for anything, basically you're able to now place entire paragraphs, documents, sentences into a point in space and have it be compared to its colleagues that may also end up in the same space because of how these models are trained. And the ones that are not related will end up in a different point in space. Again, we'll see if I get to the visual. And then actually, I think I'll skip to the visual more. So I'll just spend 2 minutes on this, which is, of course, as we scale on the embedding side, we realize this is too much, like data being, because the embeddings are actually 768 dimensions. That's 768, let's just say, numbers for each bit of text or each bit of paragraph or context. And now you have hundreds of documents or really billions of documents, and you're comparing them. Brute force comparison, not going to work. So now you have to do computer engineering to try and come up with indexes that are more optimal. And so this thing called approximate nearest neighbor, ANN, became very popular, and various algorithms for it, one being HNSW, hierarchical navigable small worlds, which allows you to basically just do sort of constant time search in vector space. It's slightly less accurate, but you get a lot of the way there, which is good enough. Again, precision recall. If how far on that line can you walk while keeping the results faithful. And finally, can we recreate the human experience? This is the modern question. This is the current with AI, with natural language processing, natural language understanding being a lot more feasible. We started to ask, well, can we just recreate the experience of the Library of Alexandria, where we just go to a librarian, we ask a question that they perhaps are an expert about, or at least they have a knowledge about where the information lies. They grab the resources, they grab the sources from all these things that we've learned, BM25, vector search, dense, sparse together. And then in addition to that, we use those sources, those documents, as a way to synthesize a natural language response. So in any of these modern apps that use language models, you simply take those retrieved documents, create a natural language response, make sure you cite the actual documents that you're referencing so the user can check the work. And now you have a lot more of a human experience of building search. So just briefly to give you a bit more intuition around how embeddings work, I have this visual where basically, I'm going to go right to this one. Let's go to this one. So I have this visual where I have three genres or three categories of tools that humans use that I have described in one line each, and I have put them in a point in space using a model, which is an embedding model. In this case, actually a very tiny model, Gemma 300 million or 270 million, the embedding model that just came out like a month ago. And so this thing is very tiny, you can run on your phone. and I like tiny models. So you can now basically take each tool and put it in a point in space. So if I hover over this, by the way, the embedding model that placed this thing in the space only got the description. So it did not know about the title. I just made up a title just to make it easier for us to read. But we simply use the description of these things: tool for chopping food, tool for chopping and mixing food, for cutting food, tool for learning about gardening, garden landscape, decorative ground cover, sanding wood surfaces, cutting wood shapes, projecting level lines, sharpening blades. So you can see there's like a sense of direction here, where as these points were put into space, there seems to be like a cluster of food related stuff here. There seems to be a gardening related stuff thing going on here, and there seems to be a wood related stuff here, woodworking. And indeed, if I go to the next slide, basically I used the labels that I already knew about these descriptions, and I use them as color to identify what they are. Again, the embedding model did not know what they were when the embedding was generated. We're simply projecting the color on top of it as a way to read it better. And so look at that, like it very, very cleanly actually placed all the gardening stuff in one place, in one area, and the food and the woodworking stuff here. And then of course this concepts in the middle where if you hover, you say tool for digging and chopping. Yeah, it could be like for, I guess, gardening, could be also for woodworking. A glove right in the middle could be for any of them. It could be for food, could be for gardening, could be for woodworking, right? So, and if you go very far out for baking casseroles, that one for sure is not going to be a gardening or a woodworking tool. So it ends up getting pushed away as the way the model has been trained. And so one last thing about this is that if you were wondering how search works, how do you actually use this as a way to get relevant results, is, well, not only could you say pick a product that you already own or pick a product that you already are looking at and find similar ones. So let's say I say I'm looking for tools that are like gloves. I click on glove here, and it gives me the nearest neighbors around that space, right? In that space, and that allows me to hover over the other one. Let's say protecting clothing. That's kind of closer to glove than baking casseroles. Wiping hands and mouth. That seems closer than not. Gripping objects, again, it's close enough. Could be a reasonable neighbor for it. Protecting the table. You can see a lot of protection stuff going on, right? Now you might be wondering, so that's a way to get the recommendation for the nearest neighbors. You might be wondering, how come the nearest neighbors aren't actually the nearest neighbors? They seem like pretty far away. That's because what I'm doing here, and I didn't mention yet, is I'm reducing the actual complexity that is captured in this model from 300 dimensions, something like that, down to 2 dimensions, right? So yeah, there's actually that list of numbers that's produced, the vector, is actually 300 numbers or 700 numbers, I forget right now. But I'm just kind of doing this thing called PCA, which basically projects stuff down, squeezes it down axis by axis, and all the way to 2D here, which is really killing a lot of information. It is still surprising and quite beautiful that you can still see a bit of a picture of where the things ended up being, even though it's this compressed, the information. And lastly, you can of course take any query that the user wants to actually inject into this. Let's say I'm looking for a new tool for slicing, let's say. Slicing, okay, slicing seems like maybe it's in the woodworking cluster. Tools for slicing vegetables. Now it seems to be in the food cluster, right? So I wanted to do this live demo where as I type, the embedding moves through that vector space, and you can see the nearest neighbors change as well. So slicing vegetables, now we can hover over this one, which is harvesting vegetables, or this one, which is chopping food. So yeah, that's generally what I wanted to cover for this talk. Where do we go from here? There's lots of approaches that exist. I wanted to basically say that if you learn your history, if you actually look at what was going on before this current time, you realize none of the ideas are really new. We're mostly playing with scale at this current moment, and there's a lot of inspiration out there for us to build off of. A lot of the projects that I do, I realize are like projects that were already existing and people were working on 50 years ago. There's this great talk, by the way, I want to just mention, by Brett Victor, called The Future of Programming. If you have not watched it, it'll do 2 things. It'll inspire the shit out of you, and if you're like me, it'll depress the shit out of you. Like, I was very sad when I first watched it, because he's like giving the talk from a perspective of being in the 70s about the future and what it could be, and it's kind of very cynical and beautiful, and you realize just there's a lot to learn from history, and this project that people never completed that you should take on. But yeah, that's me. Thank you so much.